Hello everyone. Today we will discuss questions on probability. So without wasting any time, we are jumping into the questions. So question number 1 is E and F are two independent events independent events and probability of E is given by 0.3 and probability of E union F is probability of 0.5. Then we have to find the conditional probability, then conditional probability E bar F minus the conditional probability F bar E. So we have to find this solution. So here, as E and F are independent, we can write probability of E intersection F is equals to probability of E probability of F. Then probability of E union F, it can be written as probability of E probability of F probability of E intersection F. So I can replace this probability of E intersection F with this. This is my equation number 1. So I have probability of E union F as 0.5, probability of E as 0.3, and probability of F we have to determine it, and probability of, I can write this as probability of E into probability of F. So that is 0.2 probability of F, take it common, we will get 1 minus 0.3. So we will get our probability of F as 2 by 7. Clearly probability of F is 2 by 7. Now going back to our question, we have to find this E bar F, subtract 2 probability of F bar E. Now what is the formula? I can write probability, conditional probability E bar F is probability of E intersection F divided by probability of F minus probability of F intersection E divided by probability of E. Now we know that intersection is a commutative binary operation, so E intersection F is equals to F intersection E. So we can put the value, E intersection B is 0.5, that is 2 by 7 minus 0.5, that is 0.3. So from this we will get half 2 by 7, half 3 by 10. From calculating this we will get 1 by 70. That's the answer. Also we can easily solve this, as these two events are independent. Probability of E intersection F can be written as like this: probability of E into probability of F minus probability of F into probability of E divided by probability of E. So this will be cancelled out. So from this we can also solve it like this: probability of E minus probability of F. So before solving the question, we have to read this line very carefully, that is two events are independent or not. That's the most important question. Now moving to the second question. Next question is that it's a broad question of 4 marks. The question states that from a lot of 30 balls, so we have a lot, let's assume it like this, a lot of 30 balls including 6 defective balls. So 6 defective balls and a sample of 2 bulbs, sorry, these are not balls, these are bulbs, sorry, a lot of bulbs, 30 lot of bulbs, so including 6 defective bulbs. Okay, then it is given that a sample of 2 bulbs is drawn at random one by one, with replacement. Find the probability distribution of the number of defective bulbs hence find the mean of defective bulbs. Now first understand the question what is saying. It's saying that we have a lot of 30 balls in which 6 are defective. Then we have chosen 2 balls at a random. Now we have to determine the probability distribution function of it and the mean. Okay, so here from 30 bulbs, if 6 are defective and we have chosen only 2, so there are possibilities that let's denote this as number of defective balls can be chosen. It can be 0, that no bulbs are defective, sorry, bulbs, 1 bulb defective, or both 2 bulbs are defective. So there are 3 possibilities. So let's make the probability distribution function. Here first case, let's discuss the first case. As there are 6 defective bulbs, so number of good bulbs okay, so let's discuss the first case where let's denote this as x equals to 0. What does it mean? No defective bulbs are chosen. Okay, so what are those cases? That means that from 30 bulbs, as first glance I chose a good bulb, that means 24 divided by 30, that 24 out of 30. Now in the question it is mentioned that with replacement. Okay, so I chose a ball and then again put it into the lot, so the number of total bulbs remains same. So for second case, for the second draw, there are also 30 bulbs and number of good bulbs 24. So this is, let's cancel it out, 6, 4 and 5, 4 and 5. So 16 by 25. This is the case 1 where no chosen bulbs are defective. Now case 2, x equals to 1. What does it mean? From the chosen 2 bulbs, 1 bulb is defective. So there are 2 sub cases, that in my first draw the bulb was defective and my second draw the bulb is good, or in my first draw the bulb is defective, the bulb is good, and my second draw I chose a defective bulb. So there are 2 cases, let's mention them. First, in first draw I am choosing a good bulb, that's probability is 24 divided by 30. Now as it is with replacement, so for my second draw there will be the same number of bulbs, that is 30, and what is the number of defective bulbs, that are 6. So 6 out of 30, that's my first sub case. Or in probability and set theory, the odd means the union, and in probability the odd cases are denoted by the summation sign. Or in my first draw I have chosen a defective bulb. What is the probability of that? 6 by 30 into, in my second draw if I choose a good bulb, its probability is 24 by 30. So what is my total probability? By cancelling it, it is 8 by 25. Now the last case, that's very easy. I am choosing 2 bulbs and these 2 are defective. So what will be the probability? The probability is first bulb is defective is 6 by 30, second bulb is defective is also 6 by 30. So that is 1 by 25. That's my probability distribution. Now we have to write it in a table. So that's my table. So x can be 0, x can be 1, x can be 2. 16 by 25, that is 8 by 25 and 1 by 25. This is my required probability distribution function. Let's discuss the next question. Question number 3. What is it stating? A building contractor, this is a question from case study section. A building constructor or contractor undertakes a job to construct four flats on a plot along with parking area. Due to strike, the probability of many workers not being present for the job is 0.65. Next is the probability, that's the probability of many workers not being present for the job. The probability that many are not present still work gets completed on time is 0.35. The probability that work will be completed on time with all workers are present is 0.80. So here we are given that three probabilities, that the due to strike the workers not being present for the job is 0.65, and two other probabilities are the probability that many workers are not present still work completed on time is 0.35, and second one is probability that work is completed in time with all workers present, that is 0.80. Now let's move to the second part. Let E1 represents the event that many workers were not present. Many workers were not present. Event E2 denotes all workers are present, and event E denotes work gets completed on time. So what is the probability that all the workers are present for the job? The probability that work gets completed and all the workers are present in that time. Okay, the probability that all the workers are present for the job. That's my first question to solve. In case study problem you will get so many problems to solve. So first question is, so here probability of E1 many workers are not present is given 0.65, and it is also given that if workers are not present but still we get the work done in time is 0.35, and probability of E bar E2, it denotes that all workers are present and our work get completed in time, that is 0.80. Now in first we have to find probability of all workers are present. That is nothing but the probability of E2, and this is the complement of probability of E1. So that is probability of 0.35. Event number 2, find the probability that construction will be completed on time. It means we have to find probability of E. Construction will be completed on time. What does it mean? It's nothing but probability of E. Now probability of E is equals to, using the formula of total probability of E1 into probability of E bar E1, probability of E2 into probability of E bar E2. This total probability is denotes that construction will be completed on time. These two are sub cases. First sub case represents that many workers are not present but the work gets done. Second sub case denotes that all workers are present and the work get done. So we have all of these values, so let's put them. 0.65 into 0.35 plus 0.35 into 0.80. If we calculate it, calculation is easy, you can easily do it. The answer is 0.51. You will get calculator in the exam hall. That's it. This is using, I'm writing here, total probability formula. You can see this in your NCERT book. That's very important. Total probability and Bayes theorem, these two things. From these two subtopics, you will get a question in the case study section. Now question number 3. Question number 3 denotes that probability of many workers are not present and it is given that construction or work is completed on time. So that is my event. It is denoted by probability of E1 bar E. That's the opposite of probability E bar E1 that was given. That E bar E1 means construction is completed on time given that many workers are not present. But here it is asked that many workers are not present given that work is completed on time. We have to understand the difference between these two statements. This is very important. So in this kind of problem we have to use the Bayes theorem. Okay, we have to use the Bayes theorem in this kind of problem. That is probability of E bar E1 by Bayes theorem probability of E1. As you can see, you have to use these two theorems, total probability and Bayes theorem, in this question. If you put this all of this value, we have already calculated this value. This is nothing but the probability of E, that is 0.51, and we know these values also. So by putting them you will get the answer 0.45. So this answer is calculated by Bayes theorem. This is also very important topic for your exam. Bayes theorem and total probability. Now how can you understand where to use these two theorems? So in the questions you will see you can define these kind of events like E1 event and E2 exactly its complement. Then you will get another event E. Okay, in question, this is the format of a probability case study problem. Whenever you have to calculate this probability of E, you have to use the total probability. That is nothing but probability of E1 into probability of E bar E1 E bar E2. And whenever you get this kind of question where it is asked to calculate this probability E I bar E, then you have to use the Bayes theorem. This question is very much important for your boards. So moving on to the next question. Question number 4. Here question number 4 is for any two events A and B. So here it is not mentioned that they are independent or not. Probability of A is given, that is 4/5, and probability of A intersection B is also given, that is 7/10. We have to calculate the probability of B bar A. Okay, so let's calculate it. Conditional probability B bar A. Actually this sign means you already know about that B event happen given A happens earlier. Okay, now what is the formula? A intersection B divided by probability of A. Now we have these values 7/10 and 4/5, that is 7/8. An easy one, an easy problem. Now question number 5. Question number 5 states that A and B are two independent events. It is given that probability of A is 1/3 and probability of B is 1/4. Now we have to find probability of B complement bar A. We have to find this conditional probability. Now how to find it? Now it is given that A and B are independent. Okay, now you can easily see that. What does it mean? Probability of the event B complement given that the A event occurs or happens first. Okay, so A happens, then find the probability of B complement. This is nothing but the complement of this event. What does it states? It states that A happened, then B complement happened. So what is the complement of this event? A happens but B complement did not happen. It means B happened. So I can write this as 1 minus B bar A. Now what is B bar A? That is nothing but probability of A intersection B, probability of A. Now this is, as they two are independent, probability of A intersection B is equals to probability of A into probability of B. Probability A cancel. 1 minus 1/4, that is 3/4. Okay, this portion we have to be careful. This is important. Moving forward to the next question. Here is the assertion and reason question, where I'm denoting assertion by A and I will denote reason by R. Two coins are tossed. Simultaneously. So what is the cardinality of the sample space? 4. The probability of getting a head getting two heads if it is known that at least one head comes up is 1 by 3, and my reason is let E and F be two events, then probability of E probability of F bar E is equals to probability of F intersection E divided by probability of E. Now here you can see that reason is correct, but we have to conclude that A and R are related or not. So let's find the solution. Here my sample space is, let E1 denotes that getting two head, E2 is at least one head. Now my sample space is TT, TH, HH. Okay, so my probability of E1 is getting two head is nothing but 1 by 4. As you can see, there is only one case, HH, 1 by 4, and probability of E2 at least one head is 3 by 4. Then we have to find the intersection, probability of E1 intersection E2 is nothing but 1 by 4. As you can see that getting two head and also at least one head is nothing but HH. Now we have to get this conditional probability, that what is the probability of getting two heads if it is known that at least one head comes up. So that's nothing but this conditional probability. This is probability of E1 intersection E2 divided by probability of E2, 1 by 4, 3 by 4, that is 1 by 3. So my assertion is correct and reason is also correct. So our correct option will be option A, which denotes that both A and R are true and R is the correct explanation of A. That's a question from assertion reason. That's quite important. Let's move to the next question. Question number 6. 6 or 7. Question number 7. So here is also a broad question. Question number 7 states that in answering, that's also an important question. In answering a question on a MCQ test, a student either knows the answer, or guesses. You all of guys can relate that for a given question, either you guys know it or you guess it. Now let 3 by 5 be the probability that he knows the answer and 2 by 5 be the probability that he guesses, assuming that a student who guesses and corrects the answer with probability 1 by 3. Then what is the probability that the student knows the answer given that he answered correctly? Now let's read the question that in a MCQ test a student can correct the answer, can know the answer or guess it. These are the two cases. And the probability of the student knowing the answer is 3 by 5 and the student guessing the answer is 2 by 5. 3 by 5 and 2 by 5. Now that the probability of student who guess and corrects the answer is given by 1 by 3. Now we have to find the probability that the student knows the answer given that he answered correctly. So let's find the probability. As you can see in the question, there are two cases were mentioned, that a student either knows the answer or guesses. So here two cases are already mentioned, so we will consider these two events as E1. E1 denotes the event student knows the answer. Student knows the answer. Event E2 denotes student guesses the answer. Now probability of E1 is given 3 by 5. Probability of E2 is 2 by 5. Now let A be the event which denotes that the answer is correct. Now it is given that you can easily see that if a student knows the answer, then he will definitely correct the answer. It is obvious that a student knows the answer, it is given, then he will definitely correct the answer. So this is a possible event, and we know that the probability of a possible event is nothing but 1. Okay, so this is an important case, that a student corrects the answer given that student knows the answer. Then it is obvious, if a student knows the answer, then he will correct the answer. So that's the probability of 1. Now it is also given that a student guesses and correct the answer. Then it means it is given that probability of A bar E2, that a student guessed it and corrected it, that is 1 by 3. Now I have to find this probability E1 bar A, that a student knows a student corrected the answer. A probability of that student knows the answer given that student corrected the answer. Okay, so I have already mentioned that whenever you have to find this kind of probability, you have to use the Bayes theorem. So using Bayes theorem, I will get probability of E1, probability of A bar E1, probability of E1, in denominator there will be the total probability. So after putting the values, I will get 3 by 5 plus 2 by 15 that is 3, so 9 by 11. Okay, so in the exam, if you write this E1, E2, A bar E1 and A bar E2 probability right, you will get 1 mark. That if you write this and this, you will get 1 mark. If you calculate this, sorry, not 1 mark, you will get 2 marks for just writing these 4 probabilities. You will get 2 marks. This is a 4 mark problem. Then if you write this, that using Bayes theorem and this formula, you will get another 1 mark, and for this calculation you will get the another 1 mark. So this is how the a 4 marks question is divided in terms of marking. Okay, let's move to the question number 8. So question is, a box contains 10 tickets, 2 of which carry a price of rupees 8 each, and 5 of which carry a price of rupees 4 each, and remaining 3 carry a price of rupees 2 each. Full stop. If one ticket is chosen at random, find the mean value of price. Okay, so we have to whenever you get this mean and standard variation type question, you have to determine the distribution, probability distribution function. Now let's read the question carefully. A box contains 10 tickets, 2 of which carry 8 rupees 8 price, 5 of which carries rupees 4, and remaining 3 carries rupees 2. So if I draw a ticket random, then let's denote this random variable x as the price, the prize money. What are the possibility of them? That is rupees 2, rupees 4, or rupees 8. There are three possibilities that if you draw a ticket, then you will won the prize, any three of it, any one of these three. Then let's calculate the probability distribution function. Probability of x equals to 2 is that there are 3 carry a price of 2 rupees 2. So out of 10, there are only 3 tickets which carry the price of rupees 2. So it means that probability of x equals to 2 is nothing but 3 by 10. Probability of x equals to 4, here are 5 of which carries the price of rupees 4, so that is 5 by 10. Probability of x equals to 8 is equals to 2 of which carries rupees 8, so 2 by 10. So our probability distribution function will be, let's make a box.
ওয়ান ইন্টু একটা ছ নম্বরে অফ এক, তার মানে একটা ইন্টু কি,
So
মাসের
let's
মধ্যে
write.
একটা,
Here
মাসের
I
মধ্যে
will denote the x and here my probability function. So x can be 2, 4 and 8. Here I will write the total.
শিক্ষণীয়,
So that is 3 by 10, that is 5 by 10, and that is 2 by 10. If we sum it, we will get 1. That's kind of obvious. So now we have to find the mean of this. So what is the mean?
আচ্ছা আমাদের এখানে কি
Mean of
বলছে,
price is
এই অপলায়ন
xi
অপলায়ন
pi
শব্দ ছাড়া
divided by xi.
তুলনামূলক হয়ে সব
So
পরিবর্তন
let's
হয়েছে,
2 into 3 by 10. Xi denotes these values, xy denotes these values, and pi denotes
লেখো কি
these
সমান
values.
লেখো,
So let's calculate the
কি
mean.
সমান, আচ্ছা
2 into
দাঁড়াও
3
দাঁড়াও
by
দাঁড়াও
10
দাঁড়াও,
into 4 into 5 by 10, sorry, plus
মনে করি
5 by 10,
মূলধন পি এবং বার্ষিক সুদের হার 8%,
8 into 2
মনে
by
করি
10, divided by 2 plus 4 is 6
এবং বার্ষিক
plus 8
সুদের
is
হার 8%,
14. So from this I will get 3 by 5 plus 1, 2,
সমান
2, 2 by 5, that is 8 by 5,
এসআই ইকুয়াল টু
that is 14,
8,400, 8,400, পিআই ইকুয়াল টু
10
চশমা ধরে,
plus 11, 21
চশমা
divided
ধরো,
by 14,
পিআই ইকুয়াল টু
so that is
8,612 টাকা,
21
আগে সরলসূত্র
by 70, that is nothing but if we cancel by 3 by
পিটা থাকবে,
10. So that's the mean.
পি আর দুটোই থাকবে, কারণ দুটো বলে দেওয়া হয়েছে, ঠিক আছে, একটা ইকুয়েশন বানাও তাই বলি, একটু মাঝে দিয়ে আমি করাচ্ছি, স্টুডেন্ট যদি স্টুডেন্টদের
So the next question,
এটাই না তো, এটাই লেখো, পরিবর্তন পদ্ধতি হচ্ছে পদ্ধতি হলো যে কোনো একটি সমীকরণ থেকে এক্স বা ওয়াই এর মান
question number
বার
8,
করে
sorry, question number 9.
অন্য
Question number 9 states
সমীকরণ,
that two cards
ঠিক তো ঠিক আছে, কি
are
এন,
drawn
এখানে কি এখানে, ও যেখানে লিখেছিস না এন, ওটা এন অবজেক্ট কি করবে,
successively
ভুলে গেছি কি হয়েছে, বার করে অন্য সমীকরণে বসাতে
with
বসাতে
replacement
হবে, দেখো স্টুডেন্ট এক্স, ভালো করে বুঝবে,
I have Sid Kaushik, with replacement from a well
আমার ইচ্ছা হলো 2 নম্বর সমীকরণ, এটা একটা, এখানে 2,
shuffled
আমি 2 নম্বর সমীকরণটাকে লিখতে পারি, পি এক্স প্লাস 4y ইকুয়াল টু 0, পি এক্স ইকুয়াল টু 4y
pack
কাটলে
of 52 cards.
তাহলে এক্স এর মান কি হয়ে গেল, -4/2 ওয়াই,
Find the probability
এক্স এর মান এটা লিখে দাও, পরিবর্তন পদ্ধতি পদ্ধতি
distribution of number of probability distribution
প্রথমে লিখে দে, পি আর থেকে যাবে কিন্তু, হ্যাঁ
of number of
1 নম্বর
spade cards.
সমীকরণ থেকে
So two cards are drawn from a 52 cards deck. So what is the probability distribution? So let's denote the random variable x as the number of spades card, spade cards
target is
drawn
easy. Then the even move to this stage here. Then minus the revenue variable minus split cards minus
number of spade cards drawn. That will be from two cards. You can draw none of them. You can draw one spade card, or you can draw two spade cards. Okay, so now I have to calculate the probability distribution. So for the first, if I do not take any spade card, so there are remaining 39 cards from 52 cards. So I can write the probability at probability of not spade card. There's a 3 by 4, so that is 3 by 4. So here are the two cases actually, that I am getting a spade card or not getting a spade card. So in first draw, if I got a spade card, that's probability will be 13 by 52, and this is with replacement. So I have to put this card back to the deck. Next will be 39 by 52, plus if I didn't get any spade card in first draw, that is 39 by 52, into in second draw I get a spade card, that is 13 by 52. So that is 1 by 4, that is 3 by 4, that is 3 by 4, that is 1 by 4. This is nothing but 3 by 8. Now probability of x equals to 2, that's quite easy. 13 by 52, again 13 by 52 as with replacement. We have to be careful this with replacement or without replacement word. So this is equals to 1 by 4, 1 by 4, that is 1 by 16. So let's make the probability distribution function. X equals to x, so my distribution 0, 1 and 2, so that is 3 by 4, 3 by 8 and 1 by 16. So that's my probability distribution. Let's move to the next question. Question number 10. A pair of dice is thrown. Pair of dice is thrown and the sum of the numbers appearing on the disc, on the dice, is observed to be 7. Observed to be 7. Find the probability that the number 5 has appeared
না বাবার যখন বাবা যখন বেরিয়েছে তখন কেকটা খায়
on at least
কেকটা সঙ্গে আছে বিস্কুট খাওয়ার
one
সময়
die.
দেখলা বিস্কুটটা যে খালি হাত থাকতে আর বিস্কুটটা
So let's answer this question. It's stating that a pair of dice is thrown and the sum of the numbers of the two dice are is 7. So we have to find the probability that the number 5 has appeared on at least one die. Okay, so let's denote the sample space at first. What is the sample space of this problem? My sample space will consist uh, 36 elements. And what is my event that after throwing the die, after throwing the die, sum of
সোমেতে কি পারবে সোম
faces
বুঝতে পারবে
7. So my events consist 1 6, this kind odd of pairs, 2 5, 3 4, and reverse of it 4 3, 5 2, and 6 1. That's my event. Now I have to check the probability that 5 appeared at least once. So let's denote the event F as 5 appeared on at least one die.
যে কোনো একটা সমীকরণে আর এর মান বসিয়ে ওই যে পি আর বাই এটা বলি আগে দেখো 1 নম্বর সমীকরণ দিয়ে
Now
পাই
I have to find the probability of that. Find the probability that the number 5 appeared on at least one die. So E intersection F
কোনটা
consists the F. Okay,
এই একটা গেল
so let's find the probability of F
এই একটা তাহলে গেল কোথায়
bar E. What does it mean? That it is given that sum on the face is 7. We have to find the probability that 5 appeared at least once. So this is denoted by this condition probability, that given that sum is 7, sum of two faces are 7, our 5 appeared on at least one die. Okay, so using the condition probability formula, that is F intersection E divided by FE. Let's put the value, that is nothing but probability of F, probability of E. Now F consists 2 by 36, as sample space consists 36 elements, and probability of E consists 2 here and 6 by 36. So 36 cancel. My answer will be 1 by 3. Okay, so that's the answer. That's much today. Thank you everyone.